And next, we're going to hear from Gero AI, which is one of the top companies in the longevity space. They're working on real drugs with real AI for a long time, way before AI was a hype thing. We invested at VitaDAO in the company. Highly recommend checking it out. I'm honored to introduce Peter Fedichev.
Well, thank you very much. Well, good evening, and well, so many people. So probably longevity is of an interest to many. Well, my name is Peter Fedichev. I'm a co-founder of Gero, and today I'll try to give you some non-orthodox view on what's going on in the longevity field, and what's most important, how this thing is becoming increasingly commercial. So, change. We have a high-tech device there. Okay, so just a few years ago, if I wanted to talk to people about longevity, I would be telling strange stories, you know, about demographic transition, about silver tsunami, about aging population, about having many people getting to chronic diseases and so on. But what happened over the last few years is that people who are not related to longevity medicine, good old pharma, I mean good great pharma, Novo Nordisk actually produced a drug that has certain attributes of longevity medicine. So as you may know, this funny stuff is now being sold for more than $50 billion per year. And there are forecasts that oral versions of that thing would be sold for more than $100 billion per year. And one of the companies, Eli Lilly, is on the verge of, or maybe it's already, you have to check it every day, is on the verge of becoming the first $1 trillion pharma company. So what's the magic? I mean, first of course, obese people become lean. That's cool. But the other thing is that there is increasing evidence that this drug is reducing risks of other age-related diseases. And at this time, there are multiple clinical trials already on the market suggesting that these drugs reduce the risks of other age-related diseases than diabetes or obesity by something like 30% in some cases. I mean, the exact number is not important. What's important is that if you compute it in terms of rescued years of life, that would be of order of 1 or 2 years of life. So why I'm bringing this example up? Because when things happen, it's very important to see who was right in his predictions a few years ago. So there are multiple numbers. Some people are telling that if we cure aging, we can generate, I don't know, $30 trillion or something like that. There are publications like that. There was one gentleman who is Sam Altman, somewhere around here, who a few years ago suggested that if there is a company that would extend life by just 1 or 2 years, then the capitalization of such company would be about $100 billion. So what's interesting is that now we have a data point. So we have a company that probably extended human life by a year, and the capitalization of that company increased at that moment when that kind of became clear by about $500 billion. So the order of magnitude was correct. Or maybe the dollar is not as expensive as in 2018, by the way. There could be another reason for this discrepancy. So, of course, we're not just the only people who understand that. The whole industry, I think, is now in a very interesting situation. So obviously, the whole industry is now separated into 2 camps. You have people who are actually companies as living beings, who have GLP agonists, and those who don't. And of course, those who don't know what to do. But those who have, what can they do now? I mean, if your drug is being sold for $50 billion per year, would you do another cancer drug with $5 billion of sales per year or something? I mean, what is that? So I could argue that the industry is on the cusp of understanding that the drug that is bigger than that can be only longevity drug, because everything else is smaller. So as you know, aging is not a disease, so nobody wants to develop a drug against aging. But who cares what people want? The logics of the project, of the progress, I think, is such that people will have to, because everything else is small. And as a marker of this process, I think you can see that almost any major pharma is now has a pet longevity project. Novartis with BioAge. Who else is here? Alphabet recently acquired an aging asset. We have here a huge retro bio, and well, yours truly represent a company that has just done a deal with a daughter of Roche, which is Chugai. And I think this is a trend. So nobody, I'm repeating, nobody wants to develop it, for the God's sake, not to develop drug against aging. But when you are trying to be big, you will have to develop a drug against aging, and that's what I will try to kind of show. So, once again, I'm an expert in the field, I know many funny things, but I will try to be entertaining to you, and I hope that I will present here an interesting perspective on what's going on. But before that, let me tell you another thing, is that obviously we are not the first people who are talking about longevity. As you know, there are many labs and many companies that are doing longevity drugs. And just last year, there was an announcement of X prize. So there is now a huge prize, which would go to the company that will probably extend life in a meaningful way. We have one X prize finalist here. Stand up. Let's cheer him up. Right? So this is a very, very, very well thought competition. So I looked at the lists of, cool. This is telepathy, by the way. So I looked at the list of finalists of this thing, of X prize. I mean, these are just for illustrative purposes. So I fed the list of finalists into ChatGPT and asked ChatGPT a few questions. And you know, AGI is near, and its infinite wisdom. ChatGPT informed me that almost any kind of known longevity intervention is being tested. Thank you very much. So you can see here from lifestyle interventions to digital AI platforms, pharmaceuticals, supplements, everything. Next. For those who care, all sorts of hallmarks of aging. I mean, anyone here who knows a little bit about biology of aging would see that their favorite hallmark of aging is included in the trials. So next slide. This is even more intimidating. Any kind of known mechanism that is associated with aging is also included in the trials. So with such a wonderful perspective, next slide, I asked our AI overlords what is the expected effect size of the interventions that are present in X prize. And as you can see, AI doesn't believe that there is any intervention, well, 5 years, more than 5 years. Most of the interventions have expected effect size of 1 or 2 years. And by the way, smoking is -3 years, early diabetes is 6 years. So essentially, lifestyle and nutrition gives you the same. I think this manifests a pretty miserable situation in the field. So look, with all the might of molecular biology and longevity sciences over the last many, many years, the largest effect size, which we are talking about here, is probably 5 years, which is still on par with lifestyle intervention. I mean, really, nothing beats eating less, still, which is quite discouraging, I would say. So the question is, can we do better? And to address this question, let me briefly remind you, because not everyone is old here, so I'll have to tell you what's actually going on, what is aging. I mean, first, and that's what I think everyone thinks about aging, is that with aging, we are getting more and more diseases. So this is a quite scary plot. So here you have lines. This is log plot, meaning that all the lines here are actually exponents. You can see that chances to get almost any disease associated with age is going up exponentially and doubles every 8 years, right? So that's precisely aging. Next slide. But aging is not only about diseases. So to me, these are the most scaring charts that I'm showing here. So on the left, show me your hands. Who knows what is VO2 max? Okay, quite many people. So this is basically your ability to burn oxygen, right? So this is telling you how much energy you can spend. So on the left, you can see how your VO2 max is going down with age. And by the way, it's going down with age even in people who don't have diseases. That's aging, by the way. So there are some scary levels. There is a certain level at which you cannot breathe while sleeping. I mean, that's a certain death, by the way. And then there is even a worse chart on the right. So on the right, you can see the performance of battery of cognitive tests in healthy people, by the way. And you can see that there are a few kinds of tests which are called crystallized intelligence that are kind of flat, right, before the neurodegeneration starts. But most of the tests that are related to fluid intelligence, and this is precisely your IQ, by the way, all of that is politically incorrect. As you can see, as we are aging, we are not getting smarter. And by the way, we will reach zero IQ at about 120 years old, which is not fun. What's interesting is that the crystallized intelligence stays flat, so you can still talk, but you don't understand what you are talking about. So beware of people who are talking eloquently, because sometimes they don't know what they are talking about. Right, so this is precisely what aging is, right? It's because there are many people who are thinking, okay, I'm eating well, I'm exercising, I'm not having any chronic diseases, I'm not aging, I will live forever, right? That's not the case. Aging is precisely this degradation of your physical function. Next slide. So the question is, I mean, okay, and so who cares? I mean, for the last, I think, 1 million years and a few billion years before, everyone was dying from aging. So why should we care? And I mean, isn't this wonderful and natural that we're dying from aging to, you know, free the space for the future generations, right? I mean, that's the current theory. So it's remarkable, but in nature that's not the case, because here you can see actually the chances to die as a function of age for different animals. So this is me. This is horse. Okay. This is mouse. I mean, units, these are strange units here. But look at this wonderful creature. So this guy is called naked mole rat. It lives in Somalia. It lives in colonies. It's a social, quite smart animal of the size of a mouse. They have matriarchate, so they have a dominant female there. And look at their chances to die as a function of age. So you can see this guy is kind of the same, young all the time. And he's not alone. In fact, there are lots of creatures that are not aging in nature. And this was just kind of recently proven. And think about that. I mean, people are interested in aging since, I don't know, Epos of Gilgamesh, I think, is the first one, right? So for the last 10,000 years, we're trying not to age in all possible ways. And still, in 2006, there was the first publication suggesting that this naked mole rat doesn't age. And it was done not by NIH grant, it was done by a daughter company of Google. Think about that. In our current environment of supporting science, in order to find out if naked mole rats are aging or not, I mean, totally non-interesting observation, right? This is a mammal, who cares about mammals? I'm a mammal, by the way. You have to build a company that would generate $10 billion in revenue in order to make a spin-off to fund an experiment which is essentially, I don't know, $200,000 in the making to figure out if these animals age or not. To me, that's actually ridiculous, and it's telling you why this field is actually very nascent. So the next slide. So the mere fact that this problem is not yet solved is probably because we are doing something wrong. And I had the privilege to talk to the late Leonard Heiflich, one of the very famous aging biologists. And in 2017, I think, he published a paper suggesting that probably aging is not the problem of biology, it's a problem of physics. And I actually had a job. I'm trained in theoretical physics. I was doing pretty cool stuff, but somebody showed me these naked mole rats, got kind of introduced to the field, and now what I'm doing has a name. It's Gerophysics. Since last year there is a journal, and we're kind of founding fathers of this field. So in a moment I will show you what did we learn. So next slide. So, I mean, how do you learn about aging? Of course you can study mice, worms, flies, and everything else, but who am I and who are they? I'm an apex of creation. Why should I actually study mice? So we are living now in the best of times. Humans are now the most studied animals on Earth. 500 million people have their electronic medical records in digitalized form right now. More than 10 million people worldwide are genotyped, and this number is going up. So what we do is that we are using lots of AI, of course, machine learning, whatever. We are using systems that are trying to predict the future health of people from their medical records in order kind of to predict the future. So the next slide. I mean, usual stuff. These systems, these are not language models. It's old school dynamic systems in a modern machine learning framework. We are taking medical histories to the point and we try to predict what happens till the end, and we train these models along life histories and across tens of millions of people. And what these models learn, if they learn anything, they learn how to decompose human health into clusters of diseases and aging. So these models separate aging. These models take out aging from the data is a separate process. So the next slide. I mean, this is only for fun. These models actually generate new biology. They give you more targets. And next slide, let's get it very quickly. What's most important is that these models are taking on known longevity targets and separate them into bins. What is against aging and what is against diseases. So for the first time, we see a clear picture where aging is separated from diseases, and we can actually build a strategy or whatever, talk to people who are curing diseases separately and trying to understand aging separately. Next slide. So we out-license one of such targets from these models to a major pharma, and once again, we believe that this is just the beginning. So everything that is related to age-related diseases can get now human evidence, right? Because nature runs clinical trials for us. We're all mutants. Some of us survive better diseases than others, meaning that we can use this information to build drugs. But what's most important is that we can see which genetic variation is controlling the rate of aging in humans for the first time. And this is the way how to make better drugs. So the next slide. So of course, these models actually know a lot about aging. We published a bunch of provocative statements like, we know how to measure maximum human lifespan in clinical data, which is pretty cool. It's about 120 years old. We know how to rejuvenate mice, by the way, which is quite simple. But what's most important, the next slide. We found out, and that's why not everyone likes us, we found that in humans you can stop aging, but you cannot revert it. So most of human aging is unfortunately thermodynamic reversibility. So, I mean, this is not what makes people happy about, but I think this is a very powerful statement. Stopping aging is possible within the coming years, but reversing aging is not. So the next slide. So what's interesting is that no matter how much machine learning, AI, and data were put in there, we're coming back to the roots. So exactly 200 years ago, this gentleman, Benjamin Gompertz, who actually discovered this law of exponential acceleration of aging, told that aging is a combination of two processes. One of them is the linear deterioration, and the other is chance. So this linear deterioration is precisely the damage, reversible damage, and the chance is physiological noise. So the next slide, which means that you can actually extend human life in broadly 3 different ways. So first, you can cure diseases that are end manifestations of aging. What's wrong with diseases is that even if somebody tomorrow will produce a drug that will cure all cancers, lifespan on average will increase only by 3 years. So curing diseases give you only a few years each. So if you cure all diseases, probably you can extend life by maybe 10 years. But what's most important is that if you find drugs that reduce the chance, so regulate the noise, you can bridge the average lifespan to the maximum lifespan, and this is the difference between 80 and 120. Or if you can reduce the rate of damage accumulation, you can extend lifespan, well, it's, I'm afraid to say indefinitely, but quite a lot. So basically, most of the longevity field is now working on diseases. We are talking about hallmarks of aging, which are chronic diseases. These are small effects. What's going on right now is that there is now a new breed of longevity companies that are going to the right, trying different technologies, including replacement, organ replacement, and everything else, in order to stop the build-up of damage. And kind of unique place here is in our team that we are trying to reduce the noise, to decouple aging from diseases, to make sure that the lifespan is increased by a lot. The next slide. So that's what we're doing. We're doing it in dogs, just to give you the idea. We have now lots of data. I mean, why in dogs? Because dogs, first of all, dogs are aging faster than humans. Second, dogs in this country, there are almost the same number of dogs as number of people. And the last one is that there are rumors that dogs are paying a lot for their health in this country. And FDA, by the way, is quite friendly to companies that extend life to dogs. So just to give you an example what we're doing, so on the right there is this chart like this, whatever we call the noise is related to the average lifespan in the species. The drugs that will reduce the noise will eventually produce strong effect on lifespan in humans. So the next slide. So essentially, with this kind of theoretical outlook, with lots of these real-world models, you can give kind of an interesting perspective on the current longevity industry. So I like to separate them by ambition and belief. So the horizontal axis is belief, right? So some people believe that aging is reversible, and some people believe that aging is not reversible. And the vertical axis is ambition, right? So most of the longevity biotech companies are promising you to extend life by a few years, right? So they believe that aging is reversible, but the ambition is not very high. Then there are companies like Atlas Lab, for example, which are trying to revert aging with epigenetic rejuvenation, organ replacement, and everything else. So they have huge capitals and huge ambitions, and they believe that you can take an 80 years old individual and make it 20 years old, okay? And then there are, well, pharma is obviously in the business of life extension, right? As we are talking here, pharma is extending, in a boring way, extending life, right? By introducing drugs against diseases. So they don't believe, by the way, that aging is reversible, but they are not talking about tens of years of life. And then, okay, there are some strange guys on the right. So next slide. So as you know, physics is the law, and everything else is a recommendation. There is the Marxist classics. Well, nobody should go against the second law of thermodynamics. Everyone who believes that aging is reversible will either die or become a boring farmer. There will be only a few people who believe that aging cannot be reverted but can be stopped, and these guys will produce the most impactful intervention. So I believe these interventions would be around either replacement technologies, and we have a bunch of companies who are doing that, or companies like us. And the next slide. So with that, I would say that, you know, the perspective on age, on the longevity biotech depends, unfortunately or fortunately, on your age. Meaning that, well, remember I told you that most of the effects, including the effects of lifespan, of lifestyle, are not large, right? What's most important that in humans, if you do something wrong to yourself when you are young, this is transient, right? So your body recovers so you can do whatever you want before you get your first chronic disease. If you are like 20 or 30 years old, your life expectancy could be quite large, quite long. As you know, medicine doesn't let people die anymore. So most of the people sitting here will be living for a very long time, and then actually the quality of life at the second longest part of our lives will depend on whether we will go after functional decline or not. Unfortunately, if you don't care about this, if you're too young to care about this, the current medical paradigm is to let functional decline go and trying to quench the diseases. This is the worst possible future that is possible. I mean, that means that most of the people sitting here will live to their 90s or maybe more and spend the last years in a terrible functional state. What should happen, because this is the inertial scenario, I mean, this will happen anyway. What should happen is that more people should go after functional decline, because without that, there is no value in life extension. So which means that there should be more people trying to decouple in their thinking the ideas that we should be curing diseases from the idea of curing aging. The more we focus on diseases, the more people are invited in the wrong version of the future. And this wrong version of the future is very probable. More people should be talking about functional decline. Regulators should be talking about functional decline, because otherwise things will get horrible pretty quickly. And the next slide. I mean, this is a bunch of people who is doing that. And the last slide. Well, I'll say, I tried to tell you that, I mean, many people are advocating for longevity. That's not the point. As you know, the demographic transition occurs anyway. We're living longer and have less kids. Nobody is asking us whether we want to live longer or not. We are going to live longer. The medical profession will make sure that nobody is allowed to quit early. With that, the value of focus on true anti-aging drugs should be even higher than now. That's not a matter of preference, should we be doing that biology or this biology. That's actually a humanitarian imperative to switch from diseases to aging biology. I'm just one of the guys who is doing that. There are a lot more guys who are doing that as well. And since you are here, you are probably interested in these things. Just think every next time when you are reading about, you know, another news from the longevity field. Is that still the same order of magnitude of lifestyle intervention? Or is that somebody who is trying to do, you know, meaningful intervention? We're here to build meaningful intervention, and please request meaningful intervention from biotechnologists near you.
Hi, I'm Byron. So basically I was asking, a lot of these peptide therapeutics are manufactured in China, but if we want to advance the aging biology and longevity field in the US, in San Francisco, for example, to make them much faster here to get these to market faster, because we can't wait 20 years for a lot of these.
Well, I think there are two components to your question. I mean, first is the rate at which we do it, and then where we do it. So for me as a human being, I don't care much where this drug is being produced or whatever, as soon as it is available on my market. What I think is a lot more important is how to make the clinical trials for such drugs quickly, how to do it faster. And this is a very interesting story. So back to your question, I think this country is doing a lot right now. As far as I know, there are people who are thinking a lot how to make testing of longevity drugs very quickly here. So I still think that this country can get an edge if this country introduces regulatory shortcuts for longevity intervention. And that could be a market, this could translate into market edge. So I think the country, the regulatory system that would test longevity drugs fastest will or has a chance to win.
Since you're in longevity, and you also mentioned you were a physicist, so I find this really interesting. What is your take on the potential of AI to unlock quantum biology? Do you think quantum biology is even a thing? Is that just an idea that isn't real? I'm really curious, since you're in longevity and you're a physicist, I mean, this is a space of incredible theoretical potential, but seems rather unknown right now if it's actually a thing.
Mm-hmm. Well, that's a great question because, well, obviously we are made of molecules, and molecules are governed by quantum mechanics, right? So, if you wanted to make like super in detail model of human health, that has to be quantum mechanical on some level. Well, fortunately or unfortunately, to my knowledge, there are no other than two. There are only two known examples of quantum effects in biology. So, for example, you may know that birds are seeing magnetic field.
Yeah, the birds.
Most probably with a device with a protein that uses a quantum effect. That's the only example I know. So I would say that you can do most biology without quantum physics. And think about level of how much biologists are acquainted to quantum physics, and they're still successful, right? So probably that means that quantum physics is not very important to biology. And this is actually, this is very common in complex systems. So in complex systems, many things average out and are not important. So to my belief, quantum mechanics is almost always averaged out. So I'm not a believer of quantum biology, fortunately or unfortunately. But of course for AI and everything else, well, I look at this in the following way. So in every generation, there were like top chess players, there were top theoretical physicists like Feynman, Anderson and others. They could do magic on the paper. But this is not scalable. So now, thanks to AI, we can scale up not only people of that level, but also people, I mean, nobody is teaching linear algebra anymore in the universities, but everyone knows how to code TensorFlow. So I think what happens is that AI democratizes the access to good science. People without very deep mathematical education can use very sophisticated mathematical tools under the hood of all these systems. So that's how I think linear algebra is becoming available to biologists, right? So that's where I think there is a potential of AI. You are getting essentially a top-notch analytical calculator into any biological lab right now. And that's, of course, a huge acceleration of progress.
Peter, thank you so much for your perspective. It was great. Two questions. One, thanks for increasing the dog's lifespan. How human can get that? Like, what's your action on that direction? And second, amazing as you speak, what can I do today? Because you have a lot of medical data, so I'm wondering what can I do today?
I can ask, other than suggesting to get a dog and donate it for medical sciences, which could be less practical. Well, the most, at least for me, scary observation when I look at the data is that the functional decline is linear and doesn't depend on anything, right? So, I mean, if you get, well, diabetes is the largest accelerator. So your metabolic health is the largest acceleration of the functional decline. So if you take care about just one aspect of your health, that gives you most, but this is still just 6 years at most. I mean, that's a lot, but still. So which means that, and I think this should be taught in schools, by the way. So for those who have kids, I think you should tell them before it's too late. So essentially your productive span, or whatever, joy span, call it whichever way you want, right? Because we're talking about function. Depends on if you think about this like an airplane or a glider that took up to a certain height and then glides at a certain constant rate, the higher you climb, the better you feel. Essentially, the better your physical and cognitive shape is at about 20 to 30 years old, the longer is your personal trajectory. So that's precisely what people can do. It's very hard to undo later on, right? You can do with some sport medicine, you can do some, you can do some bursts of VO2 max or something like that, but these things in a few weeks get back to the norm once you, and this norm is going down. So the unpleasant consequence of this science is that to get better now, you should go back on a time machine to your 20 years old version of yourself, pump your muscles and learn another language. I'm sorry to say that. Well, I mean, that's second law of thermodynamics, right? I mean, this is reversibility. So look, I mean, for those who have kids, I think that's an interesting dialogue to have.
Okay, Peter, my question here.
Yeah, sure.
So I know you are not the clinician, not the clinical research, but
I'm a wrong doctor.
Yeah, you are the physics scientist, but you're trying to bring this new drug for the anti-aging or longevity aging. So from your perspective, what is the best way now to do the clinical research or clinical trial to prove this is a benefit for living longer or less life, not to use the disease as endpoint? Exactly.
So first of all, I believe that if the regulatory environment is such that they are forcing people to do disease first and aging second, we are doomed to have weak drugs against aging. Because almost always your aging drug is a weaker drug than a specific drug against that particular disease. So I think this regulatory trap is actually killing longevity companies right now. So to produce a drug with a large effect against aging, you have to go out of this box. And one of the examples, which is from here, Loyal, they are going to dogs, right? I mean, they escaped this disease trap by negotiating with FDA, which allowed them to go against the second date on the grave for the dogs, rather than against the disease. So I think this is actually a preview of the future. If we want to have strong anti-aging drugs, in my view, I mean, if anyone would listen, but I mean, somebody will. I think what regulators should do is the following, is that regulators should, I think, in my opinion, to understand that phase 1 is very important. Nobody is supposed to die, right? This is like totally important. And that's what I think the government should take care of. Because what happens is that investors and biotechs are testing drugs for private money, right? So the government, in my opinion, should only look at two things. That first, this is safe, so nobody is getting killed. And second is that these guys are reaching their primary endpoint, whatever it is, right? Not to torture the data of the clinical trials, just to do these things. So I believe that in an ideal world, the regulators would make longevity biotech do phase 1, like usual. Then they should allow longevity biotechs to do phase 2 against any biomarker they want, because who cares? This is not a registration. If nobody is dying and some funny, whatever, AI mumbo jumbo says that this is a good thing and there is a significance for that, let them do phase 3. And phase 3 could be a basket trial. So, for example, a person gets one age-related disease out of a basket, gets standard of care plus anti-aging drug, and we're waiting until the next disease out of the same basket of age-related diseases shows up. And this way, we can actually measure the rate of aging in a very practical way that totally doesn't depend on the biomarker from the phase 2, by the way, right? And that's exactly what people want. People don't want many age-related diseases. So in my view, that shortcut, if we're allowed, right? Phase 2 against whatever I want and phase 3 against hard indications. I think this would unleash longevity biotechnology in a true way.
Peter, this is on.
Yeah.
Oh, go ahead.
Yeah. I'm sorry, guys.
Peter, thank you very much. You know, it's good to see. I had the privilege and honor to know someone else who was a brilliant physicist in the 90s who was working with biology and everything, and after making him quite wealthy, he decided to move on and become a poet instead. So it's good, it's Vadim, Babenko,
Oh,
probably. Vadim and I are pretty
Unfortunately,
close.
I cannot make verses, so
No,
I'm safe.
no, but obviously you've taken your brilliance in science and continued it, and I thank you for that, because that is
No.
definitely the path. My question to you, in addition to, the physics, the biology, and the AI, how are you integrating, the next holy grail is the sequencing of the whole entire immune system, which there have been a couple of people who have been very successful at doing that, a company I think called Omniscope.
Mhm.
And then being able to use that knowledge to go after inflammation and all the different disease states based on the immune system, incorporating it in what you're doing.
Well, I don't know how granular I should be, because I think there are two interesting questions there. So I could reflect a little bit about the cultural difference between biology and physics, maybe. So, as you may know, physics is a science about universalities. So in physics, when you are using, like Professor Barabashi just yesterday, string theory to describe capillaries in living systems, it's great, right? So you overgeneralize in physics, right? You are trying to be as general as possible. But the mathematics keeps you grounded, right? And that's how you can do magic. Biology is kind of the opposite science. In biology, you like details, right? So you don't generalize because you don't know linear algebra even, right? So you describe what you see. So biology is producing tools, right? Sequencing, like metabolome, like proteome, right? You are generating molecular level data sets out of which you can actually generate drugs. And biology does really miracles there. The problem is that in complex systems, when you go up in scales, most of the information from the bottom scale doesn't go up, right? All liquids can be described by the same Navier-Stokes equation with just 10 parameters. Nobody cares about quantum mechanics there. So all the microscopic details die when you go up in scale. So there's emergence, blah, 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 things like that. So what I think is very challenging in biology is that why drug discovery is so difficult is because we want to act on the molecular scale and expect effects on the medical scale. And this is not allowed because there is no bridge of information there. So what I am trying to say here is that biology is superb in doing molecular level detailed description of the reality. But unfortunately, most of those details are not important on the microscopic level. So that's why only those few links that exist between these two worlds are most important, and that's where precisely AI is very helpful, because AI can look at many associations, most of them are false, and try to distill those which are possibly clinically relevant. So what I think happens right now is that AI is bridging these two worlds, like the world of microscopic emergent descriptions of physics and the microscopic power of molecular biology. You need somebody who is, talking between the scales, and this is right now the modern machine learning. That's kind of my understanding of what's going on and why AI is so much of an enabler in this situation.
Yeah. Hi there, Peter. Thank you for a great presentation. Is this okay?
Yes.
Okay, great. So when people are able to get access to something that will delay their aging process in general. Mm-hmm. However, by that time, they have already experienced degradation in one or more of the systems that interact to provide, a living body. Mm-hmm. And so, if it is possible, which I understand that it is possible, to, for example, improve the VO2 max, or improve neurological function, or improve or rejuvenate immune function, etc. So all of these in concert, to my mind, allows one to move the needle back.
Yes.
To set it back so that, in fact, it's not just you stop it where it is, but you can move it back. There might be a limit to what you can move it back, but if you can do that fairly successfully on, let's say, a dozen different systems in the body that all are degrading at some rate, depending on the injuries that they suffer during a lifetime, then it would be possible. And I want to have a little bit more hope than what you are proposing over here. Because as the other gentleman said, not everybody has 20 years to wait to find out,
Yeah, well,
whether this is going to work for us.
Well, physics is a science about universe, and universe doesn't listen to our pain, unfortunately, in some ways. Just to give you the perspective on this kind of reversible part, I like this analogy. That, as you may know, as we look at faces, we recognize age, right? We have a neural network that actually recognizes age of, this is the mating, that was required for mating, and this neural network is very good. So as you also, I think, know from experience, that if you are sick or tired, you look older. But if you recover or sleep a little bit, you look younger, right? Which means that if we look at our body shape, at our face shape, there are two kinds of changes there, right? So there is kind of progressive change that is aging, and on top of that, there are variations that are reflecting our health, more or less. So that variation, plus minus roughly 5 years, that we recognize as the wrong age compared to the passport age, is precisely this reversible component of aging, right? You look happy, you look younger. But if you look at features like the size of your nose, for example, I mean, how do you know if a person is old? You look at the size of the nose. And no amount of exercise or dieting will reduce your nose. So that's, I mean, the truth of life. Your ears and nose essentially betray your age, and they only move one way. This is called second law of thermodynamics.
My first question is, there is a number of mechanisms on cellular level that cause aging, such as chromosome shortening, oxidation of DNA, and DNA methylation. So my question is there any research currently ongoing on addressing such mechanisms and preventing them from happening? Or any discoveries made? And second is, how does such research get any funding? Because we know pretty much any biotech research has very high upfront costs, consequently very high failure risk and very low chance of returns.
Okay, first of all, I think you alluded to a very interesting thing, is that aging has so many manifestations. And as you mentioned, every year, biologists learn another way to measure something, and that something, as our nose size, ends up to be dependent on age. And there is no end to that, right? So every year we have another something that is related to aging, and this is a total mess. But still, if you look at the population, everyone is essentially aging at the same rate. So we are genetically different, different ethnicities. I mean, there is not so much variation of the rate of aging in the population. This is a wonderful example of what is in physics called emergence. Emergence is when a complex system starts demonstrating a property that doesn't exist on the level of constituents. So aging is precisely this emergent process. Everything in a complex system gets synchronized to the point that you demonstrate aging, but aging is not epigenetic drift. It's also a mutation, it's also splicing error, accumulation of splicing errors, and everything else. It's like in a flock of birds, you kill one bird, but you know, the collective is still behaving in a collective fashion. So what I think is a little bit missing in the current biology of aging, and something that will play the role in the biology of aging, is that aging is a organism level phenomenon that consists of all those things and that enforces on every constituent the force. So aging is a force that emerges in an aging organism, and you have to treat it as such. Nobody, I mean, there is this argument, I was told by a great biologist actually this, so assume that there are many processes that lead to aging, and assume that I have a drug that kills one of them. But I mean, that process cannot be the most important process, because if it were the most important processes, all the other processes would change evolutionary in such a way to synchronize, because you don't need to have a brain that would live 1,000 years if your body can only survive 50 years, right? So evolution makes all processes synchronized in such a way that they fail roughly at the same time. I mean, a little bit, maybe one later, the other early, but that's why people die in different departments of hospitals, right? There is a little bit of variability there. What I'm trying to say, that we are actually trying to play with kind of microscopic mechanistic reasoning. We are trying to force, it's like you want to kill the New York Stock Exchange by thinking which company I should eliminate by whatever procedure, right? So like index on the stock exchange is an emergent quantity, right? It's not a property of any particular company. You have stock exchange index reported as weather. This is really a property of our modern world, like your temperature, outside temperature or pressure. You have also New York Stock Exchange or Bitcoin price or whatever. There is no microscopic intervention that can kill New York Stock Exchange other than a total disaster. Why I'm saying that is that if you understand that aging is an emergent process, there are ways, at least in physics and engineering, how to affect it. But you shouldn't be thinking, you should be humble. You don't need to think that if something depends on age, then this is aging, and by acting on that, I can reduce it. Aging is a beast in a way. It's every cell in your body participates in aging.
So I have a question. You mentioned earlier about the aging cannot be reversed, but it can be stopped.
Stopped, yes.
So what do you envision the product would look like, and what exactly would that do? And then the second question is, when do you think we would achieve an era where the organs are swappable?
Okay, that's, first of all, you shouldn't listen to anyone who is predicting future, but as an intellectual exercise, let's think about it. We are now entering the territory of beliefs here, right? So I think the form factor of an intervention against aging could be a vaccine, as strangely as it sounds, because normally the damage is being removed from our body by the immune system. And there is obviously you can realistically think that you can fine-tune our immune system to go after damage a little bit harder than we do. And by the way, we are very successfully aging mammals. We're living almost 100 years. We're complaining, but look at all the other guys in our family, right? Which means that human evolution already works in order to make us even longer-lived animals. We're just a bit impatient. Meaning that we can use the tools that are already there, and the immune system presents such a tool. And I'm not a biologist, but I have respect to biology, and I don't believe that within 10 years we can provide a better scavenging tool than the macrophage. So I would rather try to train macrophages to do their work better rather than inventing the work for them. So that's why my kind of best understanding is that by fine-tuning technologies that already exist, and my first guess is the immune system, and that's why I think the truly anti-aging drug will be the first incarnation of that would be a vaccine.
Hello.
Yes.
Thank you for your presentation. I learned a lot from you. I'm a pharmacist. And I want to ask a question. During your presentation, I heard an assumption that is equal to truth, that aging cannot be reversed. It only can be stopped. So my question from you is that, what are the markers of aging that you're putting your assumptions on? Because for me, as a pharmacist, when I see a patient that comes with, let's say, the lipid profile is not okay, the glucose level is not okay, the patient is obese, or like a lot of issues. Let's say we put that patient, let's do an interference on that patient. We have a, let's say, DASH diet, we increase the exercise level, and the patient comes back, let's say after 1 year. And we see, okay, the lipid profile looks perfect, the glucose level is good, the patient looks younger. So what are the markers of aging for you that you're putting the assumption? Because for me, that patient, the biological aging to me has been decreased.
Yeah, well, thank you for your question. Of course, I'm trying to be provocative here, otherwise it would be boring. But look, I can give you like a very extreme counter-example, like immediately like punching back. So the example is this. So if we are looking at people who are 90 or 100 years old, and we have lots of people like this now, technically they are pretty much disease-free. They may have had cancer, but the cancer doesn't kill them, doesn't stick. If you look at their medical records, they are very healthy. Really, otherwise they would be dead by that time. But if you look at them functionally, they are shadows of their former selves. Who cares if they don't have disease, right? That's why I precisely put this VO2 max and IQ as like leading indications that, at least to me, are signatures of the quality of life. You don't have world-class chess players at 80 years old. right? No amount of whatever wisdom and whatever experience can do that. So, I mean, of course, if people have bad glucose, lipid levels, and everything else, then by that age they're dead already, unfortunately, right? So they survive, but functionally they are, I mean, some of these people are going to GoFundMe and buy tickets to Switzerland where they can kill themselves. So to me, this is an indication that, yes, I agree with you that that's why I'm kind of trying to make this picture. You have this decline, and of course you can accelerate your decline. I told you that if you have diabetes, your decline is even faster. Of course, if I come to you, you will help me with diabetes, for example, and I will get back to the trajectory. But unfortunately, that will be the same declining trajectory. No amount of exercise, statins, or top-notch therapeutics would bring very much healthy 90 years old individual to their functional, whatever, even 50 years old version. I mean, that's the reason, by the way, if you ask people if they want to live to 150 years old, lots of people tell no, because they understand the trap. They understand what they are offered.
Any more questions?
So what you just said is actually really the key to what the whole industry, longevity industry, is trying to do in early stage detection, early stage personalized medicine. And the sooner you can start that at a younger age, the less likelihood that you're going to have to try to reverse these problems.
Yes, exactly. But of course, we all understand that this is not super realistic. Nobody in their, good mind will go to 30 years old people with an experiment. I assume that I will give you a potion right now and would suggest to give it, to 20 years old people because they would be living 200 years. I mean, there is a huge burden of proof here. What I believe actually is that there are certain situations where people are aged in accelerated way. So, for example, chemotherapy survivors, they are like very, very much age accelerated populations. We have kids now who are better and better surviving kids' cancers, but they are also aged. And as you know, at about 25, we are losing our ability to learn, and this doesn't go by passport age, it goes by biological age. So that's why these people have less friends, they earn less money. I mean, the imprint of chemo early in life actually lives with them like forever. So these populations of people could represent populations of accelerated agers, for which I think regulators would test these drugs first. There was another question about X price.
Yes, X price. You mentioned that with ChatGPT it's likely to be below 5 years. Was that all of the most promising interventions combined, or was that the top intervention? And if the further, how would you expect them to stack?
How do I expect what?
How do you expect the different interventions to stack?
To stack on top of each other. Well, okay. Well, most of the time, small effects, I mean, like everywhere, at least in physics, last time I checked, small effects add up, usually. But the key word here is that the effects are small, but they also should be independent, and most of them are not, unfortunately. So I would say that, I'm anticipating the results of X prize a lot. So first of all, I would like to be wrong, right? Because, well, second is that what I believe will happen is that some of them will work, and I more or less hope that I know which one of them will work, but they will show small effect, and I think this will reformat the field. Right? Because now everyone lives in the expectation that we know solutions. If we AI optimize them, stack them, and everything else, we can add up another, 20 years or something like that. What I think will happen with X prize, for the first time, we will see the empirical answer, how much these things work. And I think what will happen is that people will be astonished for how not much these things work. And this, I think, will trigger the field to actually do something more sensible.
You mentioned about the functional efficiency matters more, like a fit for purpose, right? As an anti-aging, like rather than living longer, live better. So my question is like this kind of personalized profile, preventative treatment, or tracking your biomarkers. Which demographic that you see as the best, like between 30 to 40 or like 20 to 40? Which segment that you see most likely come into this category? Yeah, to do these experiments.
Where should I do the experiments? As I said, the natural rate of decline is unfortunately very slow, right? I mean, that's ridiculously long experiment. You can do two things here. You can either increase the population a lot, right? Because even rare events, slow things in a large population would be observable. And this is exactly this tame trial. Or you should go to scenarios where aging is accelerated by a lot, as I said, like with cancer therapy. So I would say realistically, I mean, assume that I give you some strange stuff that I'm telling you once again that you will be living for 1,000 years. I mean, just make a shot, pay me $1 billion and make a shot. Would you believe me? Yeah, well, I don't know. So what I think once again will happen is that these things will be tried post-reproductively in these super damaged populations, like with cancer survivors first. And then if people will see that these things are safe and working, they will be extended in applications.
So, yeah, Peter, thank you. Great talk. Have you guys figured out how are we going to run human clinical trials? What are we going to measure in, say, a year-long clinical trial of a therapy that you're proposing?
No, once again, that's a great question because, of course, I would tell you that I know what to measure even in phase 1 to tell you if the drug works or not, but who cares if this is true or not. So that's why I'm kind of suggesting that the regulators should allow biotechs to do phase 2 against anything they want as soon as it can be standardized and checked, right? About what? Which of? Yeah, but I mean, that's precisely what phase 1 and phase 2 are doing, right? So they check the efficacy, I mean, the right thing, and then they monitor all sorts of side effects. And of course, for a true longevity drug, the margin of possible side effect would be, very low. So I think most of the drugs will not progress even there. So that's why I'm advocating to test in these super aging populations, right? Because if people survived cancer, then the limits of the side effects, the tolerability for these populations would be a lot more tolerable. I'm sorry for the language. So that's why I think the way how these things will roll out in the real world would be precisely this. You're taking the most vulnerable populations with the most tolerance for the side effects. You observe what you want to see by controlling what you don't want to see. And then essentially there should be a competition of things that would be increasingly efficacious but less dangerous. And then something will pop up into the general population eventually. No, if there is anyone.
Okay, last question.
So I understand the value of extending human life, but not necessarily forgetting that we're not just human, we're a microbiome, we're a bunch of viruses that we carry around as well. Some of those viruses eat our brains, so it's nice to not necessarily keep them around long enough. So I'm just wondering, in this space, how many people are actually paying attention to that potential aspect of maybe helping us get rid of our chronic pathogens so that we can live longer, healthier lives as humans and microbiota, not humans, microbiota, and pathogens.
Well, first of all, there is a very strong evolutionary argument. So maybe aging, at least in social animals, works in such a way to eliminate carriers of chronic infections. So of course, if you stop aging, you may end up accumulating all these bad things. But I'm very optimistic here because elimination of infectious diseases already extended human life, I think, twice. So I don't think that this is contradictory aims. What bothers me a little bit more is that we are talking about longevity biotech right now here. But at the same time, we have drug resistant almost everything in the civilized world right now. And there is no